before we continue our discussion for the single amplifier biquad, I thought it would be great to give you also a revision for the inductor replacement filter. So we have this filter, but this is an example. Okay, so we have this filter available now, and we need to decide on the filter type. We need to find the gain, the frequency, the quality factor. Okay, so what do you think? What is it? What is this filter, Shabab? What do you think? I'll pause for a few seconds, maybe 30 seconds. Think about it, Shabab. If you get it, Shabab, raise your hand. No hands. Okay, you have one. We need more hands يا شباب. خلونا نحتفل بآخر يوم بالأسبوع. We like to see more hands. Okay, 3 hands now. Perfect. Okay, so let's get your feedback, Shabab. What do you think? What is the filter here?
A high pass filter.
Okay, high pass filter. محمد يقول high pass filter. What do you think, Shabab, البقية? Is it high pass filter? High pass filter. So what basically you need to do, you need to look at these op-amps. I mean, القاعدة اللي شباب دائما نقولها فرق تسد. So these op-amps, we know for sure that this op-amp will make a gain for your circuit, right? So this one will provide gain for your circuit somehow, okay? And then we know this configuration, this structure where we have 2 op-amps, and then we have 5 passive elements, R1, R2, let me call, I don't want to call them right now, but we have 5 different elements connected in such a way that gives you an inductance. So you may take this one off and replace it by an inductor, right? So this is nothing but as if you are doing this filter here, okay? This is L, and that's your 1K, that's your 100 nanofarad, and that's your input. And then you are feeding it through the gain or the non-inverting amplifier, okay? Does it make sense? واضح يا شباب how we approach the problem?
Yes.
Okay, so yes, go ahead. So basically, if you get this structure, the Antonio structure or the generalized impedance converter, make sure you are following and you are getting the same, the same components. طبعا someone will say, okay, maybe this is not, the 1 kilo ohm here, maybe it will be part of my inductor. Well, it's not the case. If you include it, you will see an inductor with a parallel resistance, and you can do it and you can find transfer function. Okay, and we did this one before, and we know of course, this one will give you an inductance. Okay, so what will be the filter type? This is a high pass filter. Okay, and to do the filter type, we need to check shabab S equals to 0, else equal to infinity. Okay, this is a very good approach. So try to get what will be the value of the transfer function if S equal to 0. And of course, your capacitor will be what? Will be infinity. So your output will be connected to 0. And of course, the SL is connected to 0 because the inductance here will be shorted and you are connecting the V out to 0, almost 0. Okay. And then at the infinity side, you will have a short circuit between the V input and V positive here, this terminal, because your capacitor now is short circuit, and the inductor here is an open circuit. And we expect to have some transfer function. So the transfer function here, this one will be equal to 0, and for S equal to infinity, we'll have TS non-zero. Okay. So this is a high-pass filter. Now, what do we know, Shabab, about the gain here? What is the gain of this filter? طبعا لما اتكلم عن الهاي باس فلتر واقول الجين حق الهاي باس فلتر I'm talking about the high frequency gain, right? So the gain at high frequencies beyond my F corner, I mean the corner frequency. So what will be the gain here يا شباب?
The resistors, the feedback one.
ايوه اللي هي لاحظ احنا نرجع للقاعده اللي قلناها من اول فرق تسود. تعال هنا وشوف ايش الكونفيجريشن. You have a non-inverting amplifier. So what will be the gain between V positive and V out?
1 plus R2 over R1.
Exactly. So the gain here will be nothing but, so the gain here will be 1 plus R, which is this one here. Let me call this one R1, this one R2. So this one will be R1 over R2, and they both the same. So I'm expecting to have a gain of 2. Okay. What about the frequency? What do we know about LCR circuit? احنا لاحظ احنا استخدمنا LCR circuit ورحنا سوينا replacement للإندكتر فقط. So what do we know about the corner frequency for LCR circuit?
Square root of 1 over LC.
Exactly. So F naught will be 1 over 2 by, مهم جدا يا شباب, 2 by, okay? Because that one will be radian per second. So this is 1 over 2 by LC, okay? We know the capacitor, it is given, that's 0.1 micro or 100 nanofarad, but we don't know the inductor. What is the inductance here? How much is the inductance? شكلنا نعطي درجات يا شباب على المشاركة عشان الجميع يشارك. Okay, what do you think يا شباب the inductance here? It should be
1K times 1K times 100 microfarad.
Exactly. خلونا نقول يا شباب عشان تكون أسهل للفهم الأود على الإيفن. Okay, and to start from here, this is R1, R2, R3, C4, R5. And we know for sure it will be the odd over the even. So the inductance here will be R1, R3, R5 over the even, and the even is a capacitance. We have C4 and R5. So R4. R4 will be here and C5 will be 1 over. So that will give you C4. Okay, because they are all the same. These two will be, they will cancel each other. So then the inductance here will be R squared times C4, and what we have 1 kilo ohm squared times 100 nanofarad, and the inductance here will be how much? It's 0.1 Henry, or let me call it 100 millihenry. Okay, and of course from here you can find the frequency to be 1 over 2 by 100 millihenry times 100 nanofarad, and that's how much? That's around 1.59 kilohertz.
Doctor?
Yes, go ahead.
Where is R4 in the drawing that you draw?
You sure?
R4, where is it?
I think it's R2.
R4, sorry, there is no R4, R2, huh? R2, it should be R2, sorry. This one R4, لأنه R4 احنا استخدمنا capacitor C4. الاندكس يا شباب اللي بالإليمنت هو بالمكان حق الإليمنت. Okay, so you are going from this way, huh? So you'll count, you count the index starting from here. And we are using capacitor for the Z4. Okay, so there is no R4 here. طيب. So what about Q يا شباب? What do we know about Q for LCR? Not sure if you still remember the equation, but see the Q of the CR is omega naught CR, right? And what we have 2 pi F naught multiplied by CR, that's 100 nanofarad. And the resistance here it is 1 kilo ohm. Okay. I am pointing to this resistance, Shabab. I'm not talking about other resistors. I'm talking about this specific resistance. That's the resistance that will give me the Q of the filter. Okay. So if someone go ahead and change this resistor, let's say to 100 ohms, I will change only the Q. لاحظوا. يعني لو رحت أنا هنا وقلت لك سؤال conceptual question خلينا نقول. If I play with this resistor somehow between 100 to 1 kilo ohm, what will be the effect on the gain? What do you think? What do you think? What will be the effect on the gain? If I change, خلونا نسميها شباب. نسميها RX. If I change RX or if I double RX, what will be the effect of the gain? The same, صح? Nothing. ما راح يسوي effect. What will be the effect on the corner frequency?
Nothing.
Nothing. لاحظوا يا شباب, that's why we need to relate the values and the elements to the specification of the filter. The only effect of RX is the Q. So if you want to play with the Q, make it higher or lower, then you want to find the value of RX. Of course, you can do that through the capacitor, but if you do that through this capacitor, let me call it CX, the corner frequency will be affected. Okay. طيب. So now what do you have? I have Q around 1, I believe.
عفوا الكيو اللي هي الكل selectivity صح؟
selectivity مش selectivity بالتحديد اللي كنا نتكلم عنها selectivity في البداية اللي هي الكيو اس على الكيو بي سوري الاوميجا اس على الاوميجا بي، لكن هي selectivity when it comes to the bandpass filter. تمام. لما تقول لي الباند باس filter I need to make it high selective filter, you need to have high Q. بس عندنا باللو باس والهاي باس بيكون عندنا peaking. تمام. We will sketch the TS for you guys, the transfer function. So let us sketch the transfer function and I will show you the effect of the Q here. So this is the transfer function, and of course we have a high pass filter, so expect to do, this is 0 from S low frequencies you will get a 0, and then until you have a corner frequency of 1.5. So this is the this is what we expect, right? But because we have a Q here, it's not maximally flat, it's not 0.7, so we have some peaking يا شباب. Okay, لأن هي أعلى من 0.7. This is okay for 0.707 Q, and that's what we call maximally flat or Butterworth. But because we have 1 that is greater than 0.7, let me draw it in another curve here. So expect to do something like this. Okay, معلش يعني it's not good graph, but anyway, this is Q equal 1, which is more than 0.707, and this one will be your regular 0.707. Okay, which is the one that most likely we are following or we are using. And of course we have our omega naught here, which is the corner frequency. And then we expect, what is the slope of this one, Shabab? What do you think? Let me
40 dB.
Come minus 40 dB. Exactly.
Why
okay.
It's minus?
And also we have a gain of 2. What else, Shabab? Can we go for infinity? Can we go for infinity? This is low pass filter.
No, we should consider the bandwidth of the op-amp.
Exactly. So there will be a roll off at the high frequency due to the bandwidth limitation. So this one will go down here, and this one due to the op-amp limitation. To be exact, it's the bandwidth limitation of the op-amp. So maybe I call this one F op-amp T, or the FT of the op-amp. Okay. So I cannot have an infinite bandwidth for the high frequency. That will be great, and that's an ideal case. You need to have, or you for sure you will get a bandpass shape out of your bandpass filter if you are using an active filter. Okay. What else? I think that's it for this. Is it clear يا شباب؟
I have a question, Doctor.
تفضل بس الصوت يا شباب أنا ملاحظ الصوت عندي واضح ولا عندي؟ Anyway, تفضل أحمد.
Doctor, why is it minus 40 dB? Why it's not minus 20 dB?
What do you think يا شباب؟
Because we have to store energy storage element.
خلونا نقول second order filter, okay? Because it's second order filter. So this is a second order filter. We're expecting to have a roll off of minus 40 dB.
Doctor,
Okay.
why it's minus? Why it's not positive here? It's high pass.
Oh, okay. I'm talking about the roll off. So imagine this one I'm talking about from here, Shabab, huh? The slope, I mean, you can take it the other way around, that's fine. But imagine I am going this way. And that's why we say this is a roll off. Okay, it's not an increase. يعني main gain of the circuit, it's 2. Then what will be the gain of this one compared to 2? It will be attenuated. صح? So that's why you will have a minus 40. I mean minus sign. واضح يا شباب? Okay. No further questions. So let me proceed with a single backward. I believe we arrived to this equation here last time. This is for the Salinki backward. طبعا يا شباب, we can do a single amplifier backward by cascading 2 filters, as we mentioned last time. So this is 1, this is second, and then we add a buffer, or even I can add a resistor here and another resistor here to get a gain. But what will be the problem here يا شباب? What do you think? ايش المشكله بالفلتر هذا؟ لاحظوا يا شباب, احنا لما نعطيكم الفلترز انا يعني we expect you to question the circuit that you have, to criticize it. Okay, so what will be the problem here? What do you think?
The quality factor is low.
Exactly, low quality factor, and we approved that through our analysis last time, and that's why we said, okay, we can perform, or we can improve the quality factor by doing, or by going to the Salinki. And actually the Salinki, the only trick he did is connecting C1 to the output. Okay, or even if you need some gain, then this one connected to the output, and then the gain is provided through these resistors. Okay, and that's the second slide here. So this is the Salinki filter, and this is the one that you will be taking in the lab. If not, you already did that. I mean, for your experiment 6 or 7, I believe. So now let's continue the transfer function here. We arrived to this one, to the blue, and let's just multiply or divide everything by G1. Okay, so let's divide by G1. Okay, and we still have some math today. So let's divide by G1. So this is VO, B is there. Then if these are divided by G1, so this one will be SC2R1. طبعا شباب, dividing by G1 as if you are multiplying by what? R1, صح? It's the same thing. So if you divide by G1, it means you are multiplying by R1. If you don't like this one, I can say, okay, multiply, okay, by R1. Okay, so then this is SC2R1 plus SC1R1 plus SC2R2. الG1 راح مع الR1 صح? Cancelled. Then S squared C1 C2 R1 R2, and then G1 will be cancelled. We will have 1 here. Then minus SC1 R1, all equal VS. Okay. Is that clear? So now let's also divide by B. I want to get rid of this B, ya shabab, from here. I will do it in the same step. So I will also do this. So multiply by R1 over B. So I will take this one off. البي راحت والبي بتطلع هنا صح؟ بس ايش البي العكس البي يا شباب هنا شفناه من اول؟ It's the K, right? So this one will be, we'll see the K here again. طبعا you can do this يا شباب, that's fine. You can do this. So this is over B. And then 1 over B is nothing but K. Okay? At the end of the day, I'm dealing with K. I'm using B يا شباب for the analysis. But in real life, we're using K, which is the gain. Okay? And of course, this is Vs. If I am dividing by B, of course, as if I am multiplying by K. Perfect? Okay, Shabab? If you don't like this one as well, we can do this. R1 multiplied by K. It is the same thing. Okay? Okay, now, so I think we are done with the transfer function. Let's take it to the next slide. Are you satisfied, Shabab? Everything looks fine for you? Any questions, Shabab? And this is actually, this is the main term of the silent key. بيكون عندك negative term in the quality factor term or the S coefficient term. فمعناته عندنا some kind of control over the quality. لاحظوا من أول كانت 1 over 3, that's it. But here we'll have some kind of negative term that will be great for us. So let's take, let's divide by Vs. And now I'm trying to find the transfer function, اللي هو V output على Vs. So I will take this one as, so this one I will do maybe red here. So this one will be V out over Vs. And of course I have K here. I have S squared, C1, C2, R1, R2. Okay. And then C2, R1, C2, R2. Okay. C1, R1. Okay. C2, R1 and C2, R2. Perfect. So this one will be S, C1, as C2, R1 plus R2 plus C1. What about C1? We have C1 from here, which is C1, R1, and we have C1, R1K from here. So maybe I can say C1, R1, and then I have 1 minus K. واضح شباب؟ واضح؟ ايش صار؟ سوينا جمعنا او عملنا common factor for C1 and R1. Okay, 1 from here and K from here. That's 1 minus K. C2R C2R there. I mean C2R2 and C2R1 are also available. And then plus 1. Of course, this is not in standard form. How we can make it in standard form, Shabab?
Divide by the coefficient.
Exactly. We need to divide by S squared coefficient. So we need to make S squared, the coefficient of S squared to be 1. So this one will be C1, C2, R1, R2, S squared plus S, C2, R1, R2, plus C1, R1, 1 minus K, and then the term C1, C2, R1, R2, plus the same thing here. And this is in the standard form. Okay. What do we know about the gain? So the gain here will be what?
1 over C1.
K over C1.
K over C1. C2.
K ها؟ K مع اللي هنا على الأوميجا براحت بتروح مع بعض اللي هي K C1 C2 R1 R2 تمام؟ على 1 over the same R2. So all of this will go, all of this will have K. Okay? Because this is a low pass filter. And then what we know about the corner frequency should be obvious. Let's make it in omega. So this is squared 1 over C1 C2 R1 R2, which is this term here, right? As I said, Shabab, this is because we make it in standard form. Then you can get all of these values. What about the quality factor? What we know about the quality factor, Shabab? خلونا أسألكم, what we know about the S coefficient? يعبر عن ايش؟ في second order
omega naught.
ايش؟
Q over omega naught.
Exactly. So ايش عبد الله عيد؟
Q over omega naught.
Q over omega naught ولا العكس؟
Omega naught over Q.
Exactly. So this one will be Q omega naught over Q, which is the S coefficient here, which is R1 plus R2 plus C1 R1 1 minus K over C1 C2 R1 R2. Okay. So let me now do what? Let me do R1 R2. This is just to verify our improvement in the quality factor. So let's use R1 equals R2 equals R, C1 C2 equals C. زي ما كنا عملنا من قبل, okay? So what will be the quality factor here? Of course, omega will be what? Will be CR over Q. And then we have C from here 2CR plus 1CR here, 1 minus K over CR. Okay, square, sorry. And then, of course, this one will go with this one, will go with this one. Okay, and what's we're still there? We have Q equals almost 3 minus K. صح يا شباب؟ لأن عندك 2 جمعتها مع الواحد صارت 3, so 3 minus K. And you can see the improvement here. We are not limited to a constant value, which is 1 over 3. Now we can play with the quality factor as much as we can, playing with K. You can make K, طبعا you should avoid using K greater or equals to 3, right? Because if يا شباب, if K equals to 3, what do you think of Q here?
Infinity.
ايش معنى infinity Q يا شباب؟ ايش معنى infinity Q هنا؟ infinite Q.
High spike.
notch ولا بيصير ايش؟
Like spike or high spike in the middle.
هاي يعني اوكي, يعني تفكيرك صحيح, بس خلينا نوصلها نحطها بطريقة صحيحة. احنا كنا تكلمنا عنها من قبل. infinite Q بتسوي لك مشكلة في stability of the system, right? It will move your poles from the left hand side or to the axis, exactly the axis. لما تكون بالجي اوميجا, لما تكون البولز moved from the left hand side to the J omega axis, معناته صار عندك ايش؟
unstable system.
unstable system or oscillation. نقولها أوضح. And sometimes I get these kind of oscillations, and if that's the case, you need to check the Q because maybe you are very, very close to the J omega, تمام, axis. So infinite Q, Shabab, it's not good for us if you want to do a stable system here. Yes, we want to have high Q if this is a bandpass filter, but you want to consider a good, not close to infinity. And by the way, for low pass, high pass, we are satisfied with 0.707. Okay. So if even with that, you can find the K in that case. طيب. So, طبعا, what do you think, Shabab, if I need Q of 0.707? كم بيكون عندك? I mean, you can work it out, I think, yeah. You can find it, Shabab. You can find the Q equal 0.707, then you can find the K. طيب, can I do, Shabab, K greater than 3? So if K greater than 3, what will be the case?
Negative quality factor.
Negative.
Exactly. So this one will be negative. And now it is the same case. You are moving the poles from left-hand side, all the poles here, sorry, the poles here, to the right-hand side of the S-plane. And now you are turning the filter to an oscillator somehow, or let me say unstable system, okay? And that's bad move. Okay, so let's continue here. Of course, this is all of what I already talked about. طبعا يا شباب, for the Q here, if you make C's the same, R the same, and then you will get 3. So this one will be what? Will be 2 from here, and then 2 plus 1, it will be 3. So 3 minus K, and of course this one will go with each other, and we are expecting to get the same same equation that we found before. Okay. Do not let ya shabab these equations scare you. Now you know how to approach the problem. You want to know what you are doing. وهذا مهم جدا يا شباب. When you deal with op-amp circuits, just make sure you are doing it very يعني خلينا نقول confident way that will lead you inshallah to the transfer function, the right خلونا نقول standard form. Okay, and from there you can derive everything. تمام. So I will, yeah, of course you can do the silent key high pass filter. The only difference you may want to do is just reversing or like exchanging, sorry, the capacitors with the resistors. So instead of having a resistor here, I will change it to a capacitor. Of course, you can see it from here, Shabab. You can see it. I will do the same thing. So I can do the same cascaded thing here. Okay. And I am claiming we'll get the same issue of the quality factors. This is what? This is a single amplifier active filter, and with 2 cascaded high pass filter. We know this is what? This is high pass filter, صح? فعندك 2 cascaded high pass filter, and we have a buffer. So you will get a nice active filter, خلينا نقول minus 40 dB. You will get some gain if you want to provide the resistors here, but the quality factor will not be good. Okay, and that's why a silent key also make another solution of this. So by connecting this term here to the output, or in general, shabab, always if you have a low pass filter, if you want to exchange it to, if you want to do it or replace it with a high pass filter, you want to just exchange the RC with together. I mean the capacitors with the resistor and vice versa. I will not do, of course, I will not do the transfer function. You may practice this one, shabab. Okay, but you will do it the same way as we did, and you should get to the point that you'll get this transfer function. If not, ya shabab, make sure you understand it very well. Okay, okay. So just a systematic way of doing it, and you may look at what we did for the low pass filter. The same thing for the silent, the Delianis friend, this one, this is a backward if you want to do a bandpass filter, and will not do the transfer function as well because you will do it the same way. Okay, you may say this is grounded, this is V out, I have Vx here, and then you need to do a KCL at Vx and you want to find the transfer function. Okay, yeah, so of course the same thing, I'll not do this one here. You have the transfer function available. So these are like kind of practice problems, Shabab. This is good for you. You want to go ahead and derive the transfer function for the high pass filter silent key and the transfer function of the band pass filter Delianis friend backward, that's what we call. After their inventors, I mean the inventors of this these filters, either the silent key or the second one. Okay, any questions so far? الآن انتهينا من السنجل amplifier backward. Any questions so far? الآن we saw that we can implement a backward filter اللي هو second order filter using only a single amplifier. Okay شباب, ارفعوا لي ايديكم just in case if I needed to change يعني. Yes, go ahead. الموجودين, let me know if you are following me. Okay, perfect. يعطيكم العافية شباب. Let's go ahead now with the last topology in filters. And this is what we call, okay, you can lower your hand, ya shabab, Moeed and Hussein, it's okay. So now we'll talk about the last topology. Let me see if I am missing something here. Okay, I think we are done with the single amplifier. So the last topology here, this is what we call two integrator loop, okay? And this is another RC circuit. Shabab, we call it op-amp RC or RC circuit because we are not using inductor here, okay? So if I ask you to do a filter that is active RC, you may consider these topologies, either an inductor replacement, a single amplifier, or even this one, the one we'll talk about. Okay. So we'll take it from here. So let's start with the high pass filter, a transfer function. So if I have a transfer function of the high pass filter, okay. What is the transfer function of high pass filter? That's K S squared over S squared plus S. This is the standard form, omega over Q plus omega squared. And of course, if I want to, I can do this as well. So I can find K V input squared equals V high pass S squared plus V high pass S omega naught over Q plus omega naught squared V high pass. Okay, so let's divide here. Divide by S squared. So if I do this, what I'm getting is about KV input equals V high pass plus V high pass. هنا بيكون عندي squared, right? So I still have an S in the denominator here. So this one will be omega over Q S, right? And this one you are dividing by S squared. So far so good? Okay. And let me do some arrangement here. Let me take the V high pass to the these terms with the one with the 1 over S to the next side. So what I will do here, so V high pass will be nothing but KV input minus, okay, V high pass multiplied by, طبعا شباب, because I have this term available, which is omega naught, let me write this one as omega naught over S. And we'll see why we are doing this. It is the same thing. So this one, omega naught over S multiplied by 1 over Q minus omega naught squared over S squared multiplied by V high pass again. Okay? Makes sense? So now, how can I do this, Shabab? How can I implement these circuits? And we'll take it as blocks. So the V high pass here, if you are starting with the V high pass, okay, and now I am starting with V high pass. To get this term, what I need, Shabab? What do you think? Can I use an integrator here?
Yes.
Yes. And then, طبعا, we are still missing the Q. The Q is not there. 1 over Q is not there. I will come to that. And then I can follow the same thing by applying another omega over S here. So this one will give me minus omega over S. This one will give me minus omega squared over S. But here I have what? Sorry, this is plus. Negative plus. But here I have a negative sign. This is a negative sign, and we are still missing 1 over Q, and we are still missing this one. So I can do here a summation. I can find an input. So this is an input coming this way. This is K. Okay. Let me move the VH, the high pass voltage here. Okay. And now I need to add the output of this stuff here. The output of this one. So I can add the output here. But the output طبعا I'm missing 1 over Q, so I need to multiply by 1 over Q. So if I multiply by 1 over Q and then feed it back, it will give me the same term here. If I do the same with this output of this one here, but then I need to multiply by -1. واضح؟ Make sense يا شباب? What we did here? And what we have يا شباب, we have an integrator here. This is what we call integrators. This is integrator. And of course, this is another integrator. And hence, we call it two integrator loop. So we are taking two integrators and we are building the filter out of these two integrators. What's the point here? Okay, let me give you a hint, ya shabab. What do you think of this output? And let me call it maybe VX. What will be VX, ya shabab? It's a high pass filter, high pass volt, VHB, which is a high pass voltage, خلينا نقول, coming from processed by an integrator. So as if you have, this is the high pass filter, okay? This is the high pass filter function, okay? This is not, this one is like the voltage. Let me find the transfer function here. Regardless, خلونا نقول normalized, okay? Normalized to V input. يعني V input is not there. يعني VHB يا شباب هنا معناته the effect of the transfer, the high pass filter. The effect of this one here, that's what I'm looking for. So it will be a high pass filter coming through an integrator, which is omega over S with a negative. Okay? And what we know about the transfer function here? So this one will go with S and we'll still have minus omega K S over the same characteristic equation. So what will be, Shabab, the transfer function here? What will be the behavior of the filter? This is what?
Band pass filter.
Exactly. So this is band pass filter. Oh, ممتاز. إذا في شيء interesting هنا. أنا عندي high pass filter. طلعت منه band pass filter. Okay. What else I can do? If you take the same thing, and let me take another color here, maybe orange, and then let me call this one, let me do it here. This is a high pass filter again, but multiplied by طبعا, omega squared over S now, because two integrator loop. So this one will be K S squared multiplied by the same term. This is what I get. This is K omega squared over S squared plus S omega over Q plus omega squared. Oh, ممتاز. What is this case? What is the filter here?
Low pass.
It is a low pass filter. فعندك يا شباب one filter topology طلعت منه أو one circuit طلعت منها high pass, low pass, and band pass. Okay, so it is a truly universal filter. And we know, Shabab, of course, we can, if we have a band pass filter, we can find an all pass filter. احنا طلعناها من قبل. all pass filter من الهاي باس عفوا من الباند باس هي constant minus الباند باس. So this is the case. All pass, it's nothing but constant minus band pass filter. So if you can apply some constant here and subtract it from the output of the band pass filter, you are getting an all pass filter. You can do the same with the notch and everything else. يعني it's just matter of playing around. يعني كان عندك لعبة وقاعد ليجو تلعب من هنا يمين يسار. So it is the same thing. You are playing with the same filter. So that's why we call it a universal filter. Okay. So the two topology, the two integrator topology here, we can kind of getting all types of filters in the same structure. Okay. What will be the gain, Shabab, for the band pass filter, by the way? What is the gain here? طبعا we know omega naught is given, Q is given. What is the gain here? Will be what?
Q times K.
ايش هو؟
Q times K.
ما اسمع كويس.
Q times K.
Q times K مضبوط. ليش؟ لأنه it is minus omega Q. طبعا minus you can take the absolute value, that's fine. So minus omega Q over omega over Q, because the S term over the S term, the numerator and the denominator here, and that will give you minus KQ. Okay. What about the gain of the low pass filter? Let me use this one in orange. The all pass filter, low pass filter. What will be the gain here, Shabab? Constant over constant, صح? K omega naught squared على omega naught squared, so the gain will be K. I hope it's clear يا شباب this stuff اللي هو الجين، لأنه you need to understand the standard form. ليش احنا نسوي يعني دائما نروح نسوي analyze ونطلع الستاندرد form? Why we are interested in the standard form? Because we can get ايش؟ the main parameters right away. We can get the Q, the omega naught, and the gain, and of course the bandwidth. You can get it from the S coefficient. So these kind of elements or parameters, if you know it, you know the filter now. Okay. Any question here? طيب, let me ask you, Shabab, how we can make the integrator? So this is the basic, or this is the heart of the two integrator loop. تمام؟ طلعت ايش؟ عندك two integrators وبعدين جمعتهم على some summing circuits. By the way, this is a summing circuit, right? Summing or summer circuit. So we are summing some output or some input to get an output voltage. So what do you think, Shabab, of integrator? How we can do an integrator using an op-amp? Op-amp عادي يعني ما
op-amp ويكون الكاباستور فيدباك اتوقع.
ممتاز. And that's what we call a Miller op-amp, okay, or Miller integrator. So this is the Miller integrator or the op-amp integrator. It is the same thing, okay. And this is CR. And of course, if you are applying this one here in this integrator, so this is one and this is second, and you want to use CR for your omega, so omega naught will be 1 over CR here, okay? And this is, of course, this is how we implement it in the op-amp. You can analyze it, by the way, but that's fine. What about the summary, Shabab? What about the summer? So this is integrators. What about the summer?
يكون عندنا برا للريزستور in the input.
You can do this, of course. We can add inputs as much as we want and then add a feedback circuit here. Sorry, feedback resistor. So then you can weight somehow your inputs. So this is V input 1, this is input 2, this is input 3, and so on. So this is what, this is nothing but a summer circuit. Next time, next class, we'll add them together and I will show you two main or famous circuits, how we can use them. That's what we call KH chain filter and the Tau Thomas filter, okay? They are very useful and very common to use. And we'll see how we can implement these circuits together. طبعا you can do it from your side, Shabab. You can implement the circuit. You have now the integrator given, and then you have the summer circuit. The only step missing is the interfacing. So you want to interface them together, and that's what we'll do, inshallah, on Sunday. Any questions so far? Okay. If no more questions, yes, Abdullah, تفضل.
عندي سؤال بس عن السيركت الانتجريتر. هذه السيركت تشبه اللو باس فلتر.
Yes.
هل معناه انه اللو باس فلتر في الهاي فريكوينسيز بعد الكت اوف يشتغل از انتجريتر؟
لا، المفترض من قبل، انت مش من بعد، من قبل بالاخير يعني. تقصد عفوا at the pole, yes, at the within the pole, معلش, within the pole, yes. It acts like an integrator at the end of the day. اوكي، يعني انت الان اللو باس فلتر بيكون عندك بالشكل هذا، صح؟ ف if you are around this area, this is nothing but an integrator here. لان احنا نعرف الانتجريتور عباره عن السلوب اللي جاي بالطريقه، يعني الريجولار انتجريتور راح يكون شكله كذا. اوكي، But if you are working with the whole region, that's a low pass filter. But we don't need to do that. I mean, at the end of the day, we want to find or do a low pass filter, sorry, an integrator only. And in the low pass filter, you need to add another resistor in parallel with the capacitor. So yes, the answer is yes. It can be viewed as an integrator, but it's around the pole. تمام؟ مش في الهاي frequency ولا في low frequency. Around the poles. Okay, يعطيكم العافية شباب. So I'll stop recording here.